Determine whether the function is 1 to 1. If it is, find its inverse. In general, if we have an exponent that's odd, then the function is 1 to 1. So to determine its inverse, what we need to do is we need to replace the f of x with the y. So we're going to write it as y is equal to the cube root of 6x minus 4. The second step is to interchange the x and the y. So I'm going to write x is equal to the cube root of 6y minus 4 and then solve for y. If I need to solve for y, I need to take it out from underneath the radical. So I'm going to raise both sides to the same power as my index. So I'm raising it to the third power. So on the left-hand side, I get x cubed. And on the right-hand side, when I take the cube root of something and then raise it to the third power, I'm just left with what's inside the radicand. So I get 6y minus 4. Now I need to continue solving for y. So I add 4 to both sides. And I get x cubed plus 4 is equal to 6y. And then I divide everything by 6. And I get y is equal to x cubed plus 4 divided by 6. Once you get this answer, then you need to replace the y with the inverse function notation. So instead of writing y, I'm going to write the inverse of x, because that's what we're looking for, the inverse. The inverse of x is equal to x cubed plus 4 over 6. So the first thing is to determine whether the function is 1 to 1. And in general, if you have an odd exponent here or an odd index, then the function is 1 to 1. Then we replace the f of x with y, and then we change the x and the y, we solve for y, and then we replace the y with the inverse function notation.